In this video, we'll be looking at what is called VSEPR Theory. Your learning objective for this, you should be able to use VSEPR Theory to predict the molecular shape of compounds, and that's going to go on page 8. VSEPR Theory stands for Valence Shell Electron Pair Repulsion Theory. It's a useful tool in predicting the 3D shape of a molecule. VSEPR examines the valence electrons around the central atom of a molecule and uses this information to determine the angle of bonds between atoms. So we're looking at molecular shape. VSEPR uses the idea that all electrons repel each other and that they will distance themselves as far away from each other as possible. And we know that from playing with magnets as a kid. If you take the two negative sides and you stick them together, they push away. Okay, so same idea. Bonding electrons and lone pair electrons generate different effects. Bonding electrons are electrons that are being shared in a bond. Note that this says shared, so we are looking at covalent compounds in this instance. Lone pair electrons are electrons not involved in bonding, but are still around the central atom. So these are the dots that are left over in an electron dot structure. Okay. Electron geometry is based on the total bonding sites around the central atom. There are 3 electron geometries you need to know about: linear, trigonal planar, and tetrahedral. These are kind of the big idea structure. Molecular geometry is based on a ratio of bonding electrons to lone pair electrons. This is a slightly more accurate depiction of what the molecule looks like. There are 5 molecular geometries you need to be aware of: linear, trigonal planar, bent, tetrahedral, and trigonal pyramidal. Make a note, if an atom has a lone pair of electrons, then it has a polar molecule because the electrons are not equally shared. Okay, this chart is something that you're either going to need to have the information memorized for or have the chart memorized, with the exception of bond angles, which aren't really important for this course. So we have our electron geometries here and our molecular geometries here. The number of electron groups around the central atom is going to determine your electron geometry, while the number of lone pairs is going to determine your molecular geometry. So we're going to look at examples on the next page of how to read this chart and use it. Okay, so here we have a couple of different Lewis dot structures. Keep in mind when you are doing molecular geometry, you are looking only at the central atom. So if we're looking at carbon here in the middle, we actually only have 2 bonding directions because these are double bonds. Okay? So if we have 2 electron groups, that means that this is a linear molecule, and that's its electron geometry as well as its molecular geometry. In our next example, we're looking at nitrogen here in the middle. We have 4 different bonding directions. So this is going to be tetrahedral. And since we have a lone pair here on the top, that means that this is going to be a trigonal pyramidal shape. Okay, our last one, we have 4 bonding angles, which means that again, this is tetrahedral. And since we do not have any lone pairs around carbon, this is also going to be tetrahedral in terms of molecular geometry. In class, we're going to look more at what these shapes actually look like in 3D. It's kind of hard to see in a picture, so we're going to spend some time building models and looking at that tomorrow in class. Okay, for your output, I want you to come up with a mnemonic, such as an acronym, to help you remember the types of molecular geometries. Remember, a mnemonic is any sort of memory trick that helps you remember them. Make sure that for this trick, however you set it up, you use it to help you also remember how many lone pairs and how many bonds each one has.